Hi everyone. The next topic is graphics that we discuss how to generate figures in R. So basically, it is not very convenient to make figures in R because we have to specify everything from x-axis to title and so on. On the other hand, there are some convenient features to generate figures in R. For example, if you would like to create the 1000 scatter plots in the same format but for the different variables, you can code everything in R and you can generate everything within a few seconds. So we discuss how to generate figures, but we cannot discuss everything, so we focus on basic ideas. So basically, there are two tools to customize graphics in R. So one is overlaying the simple objects such as axes, texts, legends, one by one. So if you add one line, you get one more layer of objects. And the other way is to change the graphic parameters by using the PAR command. And also the plot function, within plot function, we can specify several options. So basically, within one function, plot function or parameter function, that we can adjust or arrange for our favorite format. Okay, so we use the R console to explain this. Okay, so at first, I demonstrate the two examples about how to overlay the simple objects. Suppose we have x and y. X and y are randomly generated numbers. X follows normal 0, 1. Y follows normal 1, 1. Mean 1, standard deviation 1. So just random scatter plot is expected. So plot x, y, and axis f, then we don't have anything except for scatter plot. So we have x and y, and this is scatter plot. If you specify axis, x-axis, axis parenthesis 1, then you can specify the x-axis. And the same thing for y-axis, axis parenthesis 2. Then we put the scale here. Yeah, then we get this. And we want to get some vertical and horizontal line. That can be done by the AB line function. It asks this y is equal to 1 and x is equal to 0. Then box, then we have this box. Then text, we want to put center, the text center there here at the intersection. Then we can type text 0, 1. 0, 1 is coordinates, x and y coordinates, then center. So we put the word center here. Then finally, we get title. So title function, parenthesis main, equals to this. Then we get this. So in this way, we can generate what we want. Okay, so another example. Sometimes we want to overlay more than one graphs. So in such a case, at first we draw one curve, the one function, for example, and we want to have. So this is the cosine curve, and we want to add another curve, the sine curve, on the same plane. And how to do that? We can specify another function, plot of sine. Sine is ready-made function in R. Then we set the range negative pi to pi. Pi is 3.14 approximately. And we change LTY. So last time, when we make a plot cosine, LTY is equal to 1. So this is solid line. And LTY is equal to 2 is this dashed line. When we add this option, add equals true, then we overlay these two graphs. So this is convenient feature, but it only works in this format. So plot of name of the function, then range, then some other options. So these are some. This is a basic way to overlay a function. We further put legend here. So legend, we have to specify the x coordinate and y coordinates of the upper left point of this box. Then we can put cosine and sine. So this is just legend. And LTY1, 2. So basically LTY1, line type 1 for cosine, line type 2 to sine. So then we can have this solid line and the dashed line. Okay, so next example, the next two examples are using just one plot function, but within plot function, we specify several options. So data is this, x and y. So this is just random 8 integers between 1 to 10. And if we put this code, then it generates this. So you can see x, y. So this is scatter plot of x and y. And this is main. So this is title, relationship between x and y. X lab is the name of the X label. X rating for product. So X rating for product. And Y, so this is rating for service. So Y rating for service. Okay, then the Y limit 0 to 10. So this limit is, this Y ranges from 0 to 10. And X limit, we didn't specify it, but you can specify it. And PCH, point character. So each point is represented by the plus sign, and color green. So color becomes green, and the CEX 2.0. So this is the scale, the size of the plot. So 1 is the standard, so 2 is the twice as large. So this plus is relatively large. So this is how to create a graph using options within plot. And another example, the temperature in Detroit, Michigan, and the temperature in Madison, Wisconsin from January to December. This is average temperature for 12 months in Fahrenheit. And how to make a good figure? At first, that we make a graph for Michigan. Okay, so this is line graph, and we specify the range for Y, and the type is L. So L is line graph. The P is the plot, P. And the B is both line and plot. And LTY1, line type 1 solid line, and X label and Y label. Okay. Then we want to overlay this graph, but actually this time we cannot use the add is equal to T option. That can work in the specific format, but not for this case. So plot the name of the function, range for X, it works. The add option works, but here it does not work. So just we manually overlay the two plot. So to do that, we have to specify parameter new is equal to true. Then we do not renew the pane, so we overlay the graph. So we put another one, plot Wisconsin. Then we added this dashed line. So one thing we have to be careful is that this Y limit, this is 0 to 65. So this should be the same to make a meaningful graph. If we don't specify this, just adjust automatically. So we have different scale. So it becomes messy. And type line line type 2 and x lab. And x label and y label should be the same as this one, or you can just make this as a blank. So the x lab, just quotation, nothing, then it doesn't overlay. So actually that's better than this, but exactly the same one, or we specify nothing in the second plot. And finally, just in case, we set parameter nu is equal to false, so that when we generate a next figure, that we renew the pane. So we erase this one and create a new one. Then again, legend. So the same way as the last time. So then we can make this figure. So it's a lot. There are a lot of work to do to generate just one figure.